Hello everyone, welcome to the lecture and today we are going to discuss friction. So friction is a very simple chapter and concept of this chapter can be merged with almost every topic of mechanics. So from that point of view it becomes important chapter. So all of you must have heard about friction that it is a contact force. So let us first understand what do we mean by a contact force, right? So whenever two surfaces are in contact, like we have a block which is simply placed over the surface and its weight is say 100 Newton, right? So this surface is going to apply a force which is equal to 100 Newton but in upward direction. So we can say that this block A is in contact with this horizontal surface, right? Similarly, suppose we have a case like this where we have a block A and another block is B, right? So if somebody asks us like is there any contact between block A and B, so we must think in terms of force between these two surfaces. So in terms of physics we will consider two surfaces in contact only if there exists a pair of forces between those two surfaces, like one surface is applying some force to another surface, or we can say there is a force which is getting transferred through those surfaces. Here if we make free body diagram of these blocks A and B, there will be no contact surface. We can say there is no contact force which is getting transferred from surface of A to surface of B, so we will not consider here contact between these two surfaces. But if we say somebody applies some force F, say 10 Newton. Now, in this case, contact exists. So, here we can conclude that if there is a force between those two surfaces, we can consider those surfaces into contact, right? So, here we will say that surfaces are in contact. Here we will say no contact between surfaces. Contact exists between surfaces. So the point I want to make clear here is that we will consider two surfaces in contact only if there is a force getting transferred through those surfaces. That is, one surface is applying force to the another surface, only that in that case we will consider contact between those two surfaces, right? So can we write this point that if two surfaces are in contact, there exists a force between those two surfaces. And actually it will be a pair of forces, like if the surface A is applying some force F on this surface of B, in that case B would be applying equal but opposite force on surface of block A. I'm assuming that before watching this lecture all of you must be aware with the free body diagrams and basic terminology related with forces, normal reactions, etc. Right? So the point we are making clear is if two surfaces are in contact, there must be a force between those two surfaces. Right? Okay. So before starting friction, let us take an example. a practical example, right? Suppose we have a block, weight of which is 200 Newton, right? And if we apply a tiny force over this block to pull in this direction, say magnitude of that tiny force is 10 Newton. So this is related with the practical problems. Suppose we have a heavy block placed over the floor, and if we are trying to pull that block towards us by applying a very small force, in that case what will happen? Can we move this block, heavy block, with some small force towards us? No. The answer is no. Why this is happening? So just to understand this, let us first visualize the contact between these two surfaces. Here, these surfaces appear to be plain or smooth, right? But if we zoom in this contact, or we can say if we see contact between block and the surface at microscopic level, then it would be like this. Remember, there is no ideal cases in practical life. So if somebody is saying that there is a perfectly smooth or plain surface of some body, then it is not perfectly true. Means at a microscopic level there will be some undulations. So say this point is A and this is B. So that block would be like this. I'm showing like at microscopic level there will be some irregularities over the surface of block A. Similarly, if we consider the bottom surface, there will be irregularities like this. So this is contact at microscopic level. Now, due to these irregularities, there will be some interlocking between these two surfaces, right? So these are the irregularities of two surfaces due to which what we can say that there is interlocking between these two surfaces due to which interlocking is there. Now if this is the real case and we are applying some force, say like this force, what this force will try to do, this will try to move this block in the rightward direction, right? But there is some interlocking between the block and the bottom surface, so this interlocking is going to resist this movement, or we can say relative motion. So what actually is happening here is this force is trying to pull this block in this forward direction, but there is some interlocking between the block and surface. Now due to this interlocking, this block cannot move in forward direction. Hence we can say that this interlocking is providing resistance against that relative motion. So here there is no relative motion, but there is tendency to relative motion. This force is trying to pull this block in the forward direction, but this interlocking is not letting this block move in this forward direction, or we can say this is providing resistance against that relative motion. Now if we make free body diagram of this block, so can we say its weight will be acting in downward direction, there will be some normal reaction N which will be equal to weight, say this is N dash, right? So it is equal to 200 newtons, right? Here in forward direction we have a force which is equal to 10 newton. Now as we know that this block is at rest, right? This is at rest. So net force in x direction as well as in y direction should be 0. Here in y direction net force is 0 because this weight is balanced by this normal reaction provided by this surface. Now what about this forward force? So there will be a force which is parallel to this surface due to this interlocking. That resisting force, we are showing that force by say small f, right? So for net force to be 0 in forward direction, this force must be equal to 10 newtons. So this is the basic reason, right, behind that resistance, that interlocking. Now we will define that this force as a friction force. So friction force is due to interlocking between two surfaces, right? And can we say that this force will act in opposite direction, or can we say that this force will be acting parallel to the surface, or we can say it will be acting tangential to the surface, right? So here there is no relative movement, but there is tendency to relative movement. Now in practical scenario, if we keep on increasing the magnitude of this force F, suppose we are pulling a table towards us, uh, first we apply a very small force, then we increase that force, right? So what will happen? There comes a moment where that table is just about to move, or we can say like relative motion is just about to happen, or we can say that table is at the verge of movement. So can we say like at that force this resistance force is maximum? Because if we increase that force with very small amount, there will be relative movement. It means this cannot apply that much resistance. So at that instant we can say simply like that is the maximum resistance resisting force applied by this interlocking, right? And after that there will be relative motion between those two surfaces. So here important point I want to make clear is there will be some value of maximum resisting force, right? That will be called as maximum static friction. Why we are calling that friction as static? Because there is no relative motion between those two surfaces, right? So now, the second case is if we apply force larger than that maximum resisting force. So there will be relative movement between those two surfaces. Like this block will be moving over this surface. So if there is motion, this is the block, and say we are applying some 100 Newton force, or say 200 Newton force. Weight of this block is 200 Newton, and this is moving in this forward direction. So if movement, once movement starts of that block over that surface, will this surface still apply some resisting force, or can we say just to make that block moving in forward direction, do we need to apply a minimum force? Yes. So if there is relative movement, still there will be a resisting force that will be known as kinetic friction. So here, if there is relative motion between two surfaces, kinetic friction comes into scene, right? So these are the basic concepts only. Like there is some interlocking due to which there will be some resisting force. That resisting force is known as friction. If there is no relative motion but there is tendency to relative motion, in that case that friction will be known as static friction. And if there is relative motion, in that case that friction will be known as kinetic friction, right? So we can define friction force, right? So let us read that statement. Friction is a contact force, right? When two surfaces are in contact, say this surface weight is 200 Newton, force is 10 Newton, right? So these two surfaces are in contact. So here there will be a normal reaction N dash 200 Newton, and there will be a friction that will be equal to 10 Newton, right? So both this friction as well as this normal reaction, both are contact forces, right? But the force which is perpendicular to the surface, we define that force as normal reaction, and the force which is parallel to the surface, here we will be defining that force as friction, and this friction force is due to interlocking. Now when this force is going to act, if there is relative motion between two surfaces or tendency of relative motion between two surfaces, so it is a contact force. And what will be its direction? It will be acting in such a way such that it always tries to oppose that relative motion or tendency of that relative motion. And we have already discussed this, that this will be acting parallel to the surface. So friction is a contact force between two surfaces if there is relative motion between two surfaces or there is tendency of relative motion between those two surfaces, right? It is a tangential force, means parallel to the surface, and its direction on any surface. See, we can make free body diagram and we can show this friction force on both the surfaces, that is bottom surface of this block or this horizontal floor also. So on any surface, its direction will be such that it opposes the relative motion or tendency of relative motion, right? So accordingly we can decide the direction of that friction force. Now types of friction force: first we have defined it as static friction, another is kinetic friction. When static friction will be acting, if there is only tendency of relative motion. When this kinetic friction is acting, when there is relative motion between two surfaces, then this kinetic friction comes into role, right? So let us first discuss static friction. So when there is no relative motion between two surfaces but there is tendency of relative motion, then static friction acts between those two surfaces, right? Now what is the magnitude of static friction? So if we talk about, see, about direction we have already discussed. So value of static friction. So in the same example, if its weight is 200 newtons and initially if we apply 10 Newton force, there is no relative movement. It means that friction will be acting and its magnitude will be equal to 10 Newtons. If we increase this force to 20 Newtons and still there is no movement, so what does it mean? It means that now that static friction is acting equal to 20 Newton, because net force in horizontal direction must be zero. So can we say that this static friction is self adjustable, means it will act at a value which is required just to keep that body in equilibrium, right? Now if we keep on increasing this force F, so that static friction goes on increasing with the value of this force, but there is a limit, right? When movement of this box starts, at that moment there will be no sufficient friction just to oppose that motion. It means it has exceeded the maximum value of static friction. So static friction Fs, its magnitude is between 0 to some maximum value, that is Fx maximum, or and this is also called as Fs limiting. Now suppose a force of 50 Newton is required just to move that block over the surface. It means, can we say that 50 Newton, can we say that 50 Newton is the weight? Okay, so we were saying that if a force equals to 50 Newton is acting, so this is the force required just to move that block over the surface. So can we say that this is the maximum value of static friction, right? Okay, so just to move this block we require minimum 50 Newton force. Now suppose a block is placed over this block and weight of this is also equal to 200 Newton. So what we have concluded with the help of experiments, that if we double that weight, in that case this normal reaction also becomes double. So it becomes 2 times 200, that is 400 Newton, and that minimum force required to move this block, it also becomes double. So we have concluded that this Fx maximum, this Fs maximum or Fx limiting is directly proportional to normal reaction between those two surfaces. And if we write an equation, so here comes a coefficient mu s. So this mu s is known as coefficient of static friction, and n is normal reaction. Normal means which is perpendicular to the surface. Normal reaction between two surfaces. And this coefficient of friction is basically representing interlocking between those two surfaces. So if there is higher interlocking, we can say value of mu s will be higher, or we can say there will be higher regularities and that surface will be rougher as compared to surface with lower value of mu s, right? So this is the maximum value of limiting friction, but and we have already seen that this static friction is not acting at its maximum value always. It can adjust its value as per the requirement. So this acts between 0 to Fs maximum, which is mu s into n. This is static friction. Now the next is kinetic friction. So if there is relative movement, another is kinetic friction. So if there is relative movement between two surfaces, there will be kinetic friction acting between those two surfaces in contact. Between those two surfaces in contact. Right? And its value will be simply mu k into n. Mu k times normal reaction acting between them, and this mu k is called as coefficient of kinetic friction. So its magnitude is always constant, that is mu k into n, and it simply depends if there is relative motion between those surfaces, then this force will be acting. It does not depend on the forces applied on the surfaces, right? It only depends if there is relative motion, and direction will be again in the same way that it will try to oppose that relative motion between those two surfaces, right? Now we have some important points to note. So practically you must have seen this, like say here minimum force required to move that block will be equal to that limiting friction, that is mu s into n. So if there is some interlocking between those two surfaces and there will be some minimum force required to move this block over this surface, that will be simply equal to mu s into n. But once the movement has started, this interlocking becomes quite weak, right? And required force, minimum force required just to keep that block moving with some constant velocity will be somewhat lesser than mu s into n. So what is mu s into n? F minimum to move the block, right? But once the movement has started, this interlocking will be weaker, and in that case we have to apply somewhat lesser force than this mu s into n, and that lesser force is nothing but mu k into n. So here I want to make this point that mu k is always less than mu s, right? So can we write it down? First, value of mu s is always greater than equal to mu k. In some cases, we can assume both as equal, right? But mostly the value of mu s is always higher than the value of mu k. Another point is mu s and mu k will depend on the nature of surface, or we can say interlocking between those two surfaces. So these are basically representing the roughness between those two surfaces, that is interlocking between those two surfaces, right? So value of mu s and mu k, we can say, depend on the nature of surfaces. And another point, like with the help of experiments we have shown that this friction force acting on a surface does not depend on the surface area of that body, right? So the friction force does not depend on the surface area. Okay. So here we have discussed friction, what is friction, then type of friction, static and kinetic, then value of static friction as well as kinetic friction. Now let us practice an example over this concept, right? We have a block whose weight is 100 Newton. Value of mu s and mu k are given for the surface zero point 0.6 and zero point 0.5. Now we have to fill this given table. So when force applied is 0, in that case we have to tell the value of friction force, its magnitude, direction and type of friction force, whether it will be static or it will be kinetic, right? So if this force F is 0, in that case there will be no tendency of movement, right? So this will remain at rest and there will be no tendency, so there will be no friction. So we can say null, 0. So this is the first case. Now in second case, if we are applying force 10 Newton, in that case what type of friction will be acting? Its magnitude and its direction, right? So here in this case, let us calculate Fs limiting. It will be simply mu s into n. So if we have a block weight of which is 100 Newton. So here we have normal reaction n dash. This will be equal to weight only 100, right? So from here, the limiting friction will be acting as 0.6. Value of mu s is 0.6. This normal reaction is 100. So it will be simply 60 newtons. And F kinetic, that will be mu k into n. Its value is 50 Newton, right? So for the second case, the applied force is 10 Newton. So will there be any movement? No, there will be no movement. It means the type of friction would be static. Its value will be equal to this applied force only. It will not be equal to mu s into n. That is the maximum value of this static friction, or we can say limiting friction. So its value will be 10 Newton only. And the direction will be, this is in forward direction, so this friction will oppose that tendency of movement, so it will be in backward direction. Backward means opposite to the applied force. Now if we increase this force to 20 Newton, still see here maximum friction force or the limiting friction is 60 Newton. So if we are applying force lesser than this limiting friction, there will be no movement and friction will always be equal to applied force. Can we conclude this? So it will be same, it will be 20 Newton static. Now here this force 60 Newton is applied, right? And the maximum friction, static friction is also 16 Newton. Kinetic is 50 Newton. So unless we apply force greater than this 60 Newton, there will be no relative motion. And if there is no relative motion, the force of friction acting will be always static. So again it will be static, it will be in backward direction and it will be equal to 60 Newton. Now if we apply 61 Newton force, so this force is quite larger or larger than this limiting friction. It means the movement between two surfaces has already started. So there will be some relative movement and the force of friction will be acting will be kinetic. And kinetic friction will be equal to mu k into n. it will be in backward direction. If 70 Newton, same, again 50 Newton. That kinetic friction does not depend on the magnitude of applied force, it only depends on the relative motion, and it opposes the relative motion, right? It will be kinetic friction. So I hope all of you have understood that the basic concept of friction, type of friction, and we have uh, practiced an example over that friction. So in next lecture we will be doing some another problems based on static and kinetic friction. So that is all for today. Thank you so much.